mm, about tree and tree I discussed about. Mm, mm, mm. The name of topic was tree. Trava, tra, tra, traversing. So uh, today in the first class, in BS class, I mainly discussed about the traversing in tree. So how we traverse in tree. So there are three ways to traverse in a tree. Firstly, we use in order, then pre-order, then post-order, and after that we learn about the uh, binary tree, how we use the binary tree by using the traversed or the displayed mm, uh, uh, version of the uh, tree. So for traversing of the tree, how we traverse any tree, so you can see by an example. So in traversing we use three techniques for tree traversing. So it is the tree traversing. We use three method. First one is in order, order, pre-order, and final post order. So I will show these all for a single tree. Suppose there is a tree here, A, B,
लौकत नहीं क्या मैं
so
और लिखा का था और ये होने दे हाँ होने ओके आगे बढ़ जाते हैं होने हो सके अब आगे बढ़ जाए पे
आगे बढ़ी मैंने
बढ़ बढ़ लो की
हिट करी
हाँ और ये आगे हाँ बस बस तक और ये पीछे तक मैंने हाथा बा बस ठीक है
fine.
हाँ
So this is the traversing method of tree. So we can take an example. Suppose we have to use this method in order. So in order we use there are three positions are present in any tree. First is root node, and root node has two main things, that is left and right node. So here is the left and here is the right. Fine. So this format is used for traversing in order. Firstly we find the uh, left branch, then root, then right. So we can easily share. Suppose if we have a tree like A, B, C, and we can take example from here. Here is D, here is E and F. So how we can traverse or display it? So we will use here in order method for this. So in order uh, thing says means in order we follow this format, and in this format we firstly find the low left left branch. So if we come here, where is its left branch? Firstly, we denote all of these by these, like format: left, right, left, root, right, left, root, right, left, root, right, left, root, right. Fine. So now we will go to the left. So if we come to the left of the A, so we will come here B. So if we come to the left of the B, we will come to the D. So now when we find the D, we will cut it, the root, and root will be displayed here. So we will got D, and if we go to the right of the D, there is nothing, it is null. So it will finish, and when we will return to the B. If we go to the B, left is already cutted, so we will now cancel out the root, and root node is itself, B. So B will be displayed here, and if you go to the right of the B, so right of the B is what? Empty, nothing. So it will be cut out, and now when we return to the A, we will cut to the A, and when we go to the right, we will got the C. When we will go to the C, we will go to the left of the C. So left of the C, what is E? E, and we will cut the root. Then we will go to the right. Right is empty. Then we will return to C. Now C root will be cutted, and we will go to the right of the C. Right of the C, F. Left cut out, root cut out. Then F, right cut out. So this will be the final answer of the which on in order traversing. So by this way we follow the in order traversing. Fine. Again, these all are very simple. So we can write here the formulas or the expression for in order. What? Left, root, right. Finally we find to the left, then to the root, then to the finally right. And here now we three formula will be available for us. Pre-order. Pre-order. In order means what? The root was inside the left and right. In pre-order, root was where? Pre, before left and right. So root will in the beginning and then left and right. In post order, this root will be in the post, means after left and right. So how its expression seems like left, right, and root. Fine. So these are the three expressions. So we firstly know the in order. Now we are going to see the traversing by using the pre-order. So in pre-order, suppose here is expression A, B, C, D, E and F. Fine. We have to use now which pre-order? Pre-order says root will be the pre before left and right. Fine. So here is a, we will start from always here, from the top, from the root, from the parent node, from the root node. This is the root node, and it says I have need to root node, so we will simply display it. Okay. Now we will go to the left of this. So left is what? B. So B will be displayed. Now we go again the left of this B. What is D? Fine. Completed. Now we have right. Right is empty. Go to the B. B is right empty. Now go to the A. A right. Right is C. C. So C root. So C will be displayed. Now we go to the left of the C. Left of the C is what? E. So E will be displayed. Left empty, right empty is. So now we will go to the right, and we will return to the C and return C, we will go to the right of the C. So when we will go to the right of the C, we will find F. So F will be the root. Now it will be displayed. So here is the expression for this: A, B, D, C, E, F. Fine, fine. And we forward to the uh, in order. So once I will write the in order. So for in order, how we will write this? Firstly, we will write D, then B, then A, then which E, then D, and then C, then F. Fine. Now we are going to see the post order of this tree. So for post order, what I have to find first? We go to the left of this. So left of this is what? Left, not right, left. So the left is what? B, uh, B. When we come to the B, what is the left of B? D. So finally we will got here D, and when we will go to the right of the D, this is empty, so we will return to the B. We will go to the B, there is nothing in right of it, so we will go to the root of the B, so B will be displayed. Now we will go to the return to the A, then we will go to the right of the A. So right of the A is what? C. So now we will go to the left of the C. So left of the C is E. So E will be so E. So left of the E is empty, right is empty. So we will display the root. Here root is what? E. So E will be written out. So now we will return to the C. See, when we will come to the C, already we have visited its left branch. Now it has visit to uh, visit. We have to visit to its uh, right branch. So right branch in F. So we will check the F's left, nothing, rights, nothing, empty. So we will display the root. So F is root here. Now we will return to the C. So C is left here. So now it is the uh, root only, because we visited both side left and right. So after displaying the C, we will return to the A, and finally A will be also display its root. So here is the post order: E, D, B, E, F, C, A. So these are the method of traversing that we studied in the um, tree. And now we will, how can we construct this tree by using these? So we converted by tree this format. Now we will make the tree by this. So how we can convert this into a tree? So this method is called the binary tree. Draw the binary tree, and it is one of the most important uh, thing that are discussed in uh, this topic. So for drawing the binary tree, we have to need to at least two format of these. So the primary format that is required always, that is in order, and we can take one of them, pre-order or post-order, and by using these two we can make any tree. Suppose we have to construct that tree, so we can construct by using these two the tree from which we derived this format. Hmm? So here now we are going to construct. For constructing, firstly we write the in order. So where is in order? Here is in order firstly. So here is D, P, A, E, C, F. Fine. Now we can take any of them, pre-order or post-order. So suppose we have taken pre-order here, fine. In pre-order A, B, D, C, E, F. So how we can now start by formatting the tree. So for formatting the tree, we will start with pre-order or post-order, whatever is given here. But the in order is always fixed. In order A will always given for the draw a binary tree. So we know that in pre-order the node root node contains in the first. This is the root node. So by seeing the pre-node, we can identify where is the root node. We can't find in this which is a root node from where tree is starting and started branching. So for this, we will see in the pre-order in the first position, and in the post order we will see at the last position. If here there will be a post order, we will go to the last, and the digit which will present in the last, that will be the our root node. So we can easily draw here a, this is the root node. So we will go to the in order. So in order, where is a? Here is a. So in a, there are something in left side, there are some digits or the letters in the right side. So easily we can divide them in two branches. In left side there is db, fine, and in right side there is ecf, fine. So these all things happens in several steps. So this is the first step, and in second step, so here is our second step. In second step, what we will do, we will branching this all. So now we will go to the b. Where is b? B is here. So we will go to the b. What is the right of the b? A, already it has denoted. So we will go to the left of the b. What is left of the b? D. So now we will start a. We will write here similarly, and here is b, and right of the b, what is d? So here we will write d, fine. Now again d. So what is the right of the d? B and a. These two digit and digit time, digit letter. These two letter, both the letter are already displayed in the tree. So we will go to the right left of the d. So what is the left of the d? Nothing. So there will be nothing. So we will display the d again in the right manner, and this will be the d, fine. Now we will come to this part, ecf. Not we, I coming by remembering, but we are following the order. We visited to the a, b, d, and now we are going to the c. Where is c? Here is c. So if you see the c, what is the right of the c? So we will find f, and left of the c, e. So we can easily write in the next step for the that a, b, d, and here c, and the left of the c, e, and the right of the c, f, fine. Now one by one, after c, e. So we will come to the e. What is the left and right of the e? Already a and c are displayed, so we will write nothing. A, b, d, c, and e already displayed. Now we have only f. So if you come to the f, we go to the f here. So what is the left of the f? C, already displayed here. But if you go to the right of the f, there is nothing. So we'll finally display f. So this is the method of what drawing binary trees. So by using this method we can easily draw any binary tree, and for post order we'll go to the from this side to this side, uh, from right to left. Fine. So I hope you understood this, and in the next class, in the Excel class, we mainly discussed about the module that is quite discrimination based and completely biased. So I don't engage in that, and I invest my time in the some other book materials. And after that, in the maths class, so explain us some questions, and then I come to the home and started reading or understanding a important concept, that is concept of routing. So we have we have to give a sir has given us assignment to construct a network that is based on VLSM, uh, vertical line uh, subnet mask. In this, there is a switch, L3 switch. Through that, there are three more switches are connected, uh, and with these all switches, from this switch 20 devices can connect, and from this 10, this 5. And now for this network, one by one, we have to find the subnet. We have to find the usable IPs, IP range, and network IP, and broadcast IP, subnet mask. So these things, and so let's get start discussing. So if we saw, this is a huge network, because it containing 20 devices, it containing 10 devices, it containing 5 devices. And so if we see this switch S1 in itself containing a huge number of devices, so we can say it a small network in itself. Fine. This switch also containing 10 devices in itself, so this can be also called as a small network. And similarly, like this network of 20 devices and this network of 10 devices, here is a small network of 5 devices, so it can be also a network in itself. So we have how many small networks? 3 networks. So we will not call it a network, because we have an entire network that is formed by mainly this switch. Uh, so this is the overall network, and this, for overall network there are mainly 3 sub networks. Small networks are also called as sub networks. So this is the subnet 1, subnet 2, subnet 3. So now we are use the IP addressing for the better or the convenience transformation and the communication between the devices in this network. And for this we will use CICD like this concept, but I will explain thoroughly how can we find. So firstly, for what so we have to provide a IP. So sir has given us that your IP should be started with your roll number, so I will start my IP with the roll number 43.0.0.0 format. Huh. So I have given to this IP to the this is my IP ID, you can so say, and I will start giving IP from here. So if we see, where is our first device in the first subnet? Here. So in this we will find the all the several uh, hmm, uh, several what several terms for the subnet one. So I will mention here subnet one. We are finding for just this. So how many devices are available in this? 20. So how many uh, hmm, uh, hosts we have? Hosts 20 host, but how many we have to need? So for 20 devices, how many IP addresses at least we have to need? So for 20 devices we have to need at least 22 IP addresses. Why two more? I'm saying because 20 plus 2, and into this there is two more main important IPs are considered. That is the network IP and the broadcast BROA cast IP. Fine. So overall we have 22 IPs, and for 22 IP addressing, if you go to the IPv4 addressing system, we have to need to how much host bits for fulfill the this requirement. So host bits numbers follow a trend of 2 to the power number of host bit. So if we take the host bit 5, we have the how much? 32 host, but already we have 2, one in the form of network bit and one in the form of broadcast bit. We have only 30. So fine, it is enough for the 20 devices. And if we talk about one more thing, that is the net subnet. What is net? If we divide the number of uh, host by the host bit, this is the number of net bit or the network bit. So 27. And we can also give the IP address to this one like this: 43.0.0.1/27. That is our network bit. Fine. Now we have to find the what is the network IP. So network IP, already we have said, network IP is the most first the fastest IP is known as the network IP. The fastest IP that is given to the device is not first. Just before the first device, that EP is uh, called the network IP. So we can easily 43.0.0.0. And what is the range of IP we have taken? So range of IP that we have taken is 32. So from where 32? From here 1, from 1 to 32. So our real IP is not starting from the 1, starting from 0. So it will be into the 31. But the last device we are going to provide the IP, it will be not the 31, it will be the 33.0.0.20, because we have just 20 devices. So the usable IP we have just how much? 22, and remaining how much? 8 and 10 are unusable IPs. So but those will be the unusable, and that can't be used in the second subnet. So the second subnet will start from where we have used till the how much? So the range, firstly I have to write the range 32.0.0.0.1 to 20. fine. And the broadcast IP, that is the last one. Broadcast 43.0.0. How we can write here 31. Fine. Now the next IP that will given to the second subnet, second device, will not with the start with the 32, because we know that the first IP that is given to any network will be the network IP. So this, the first device that contained with 33.0.0. Which 32, not 33. And from 33 we will count for the 10 devices how much it will contains. So 33, 34, 35, 36, 37, 38, 39, 39, 40, 41, 42. So 42, 43 dot
इसमें पढ़ा जाएगा
42. And the broadcast IP for this is 34, 43, not 43, but we will take how much for this, for the requirement of 12, for the fulfillment of requirement of 12, we will take almost 16 hosts, and that will be count from where, from the here, where is the first one is 20. So I hope you understood this, and I will explain the remaining all from the next day. And I will try to explain the actual concept of all the routing and subnetting or everything in the network. Almost I will summarize those all. Fine.